Okay, I got Fiji water. All right, so I got Fiji water which has silicates in it. It's supposedly naturally from the island of Fiji. I, of course, am skeptical always. I feel like if I look at the label, it was bottled in Deer Park or something. But it says it's from the island of Fiji. Okay, and I guess the water in Fiji has a lot of silicates. Now, silicates, of course, are going to be some particles undissolved in the water that they're naturally occurring. And the reason why this isn't frozen is the silicates have lowered the freezing point, right? They've got in the way of that, squirrel trying to get to the other side of the road. So it's not frozen. So what I'm going to try to do, though, is I'm going to try to slam on the bottom of this, okay? And by slamming on the bottom of this, what I will be doing is giving the squirrel energy to get to the other side of the world and create a crystal, right? They're all disorganized. But what we have is a colloid here of suspended silicates, but they could actually, the water could freeze if I just apply some motion, right? I can so with a little bit of energy, I can get that water to get into the position it wants to get in. Right now it's being impeded by the silicates, but if I slam down fast, maybe this will occur. So this is lower than the freezing point, and hopefully I can cause some recrystallization by just slamming down. So here we go. And sometimes you see this, especially now it's been so cold below freezing, if you've got a drink in your car, and if you had some seltzer or some kind of other drinks that had particulates dissolved in it, it's preventing the what? It's preventing the water from freezing in that temperature. But with a little bit of motion or opening the cap up just enough to let some air out or some of the dissolved oxygens or anything in the water, okay, it'll cause the freezing. I got one more, why not? Okay? So again, the reason why it's not freezing at this temperature is because the particles, the dissolved particles, the silicates, are preventing the water. So the freezing point temperature is lower than that. But if I give it some energy, okay, and cause the molecules to create a crystalline pattern by just forcing some molecules of water into a position it wants to be at this temperature, I can create a crystal, or I can make it freeze at this temperature. Same thing, so let's try it again. So, I don't know which better, live or not. So let's get this guy out of the way, for those that want to watch him. So here's my bottle of Fiji water. And again, where is it bottled? I'm not really sure, but it definitely has something in it. So here we go, 1, 2, 3. And now you have the water freezing. This is called supercooled water. Water that was cooled below its freezing point and able to be able to freeze once I was able to either take out the solute particles. Now I'm not taking the solute particles out, but by giving the water energy to form crystals, that's making it easier for the other squirrels or other water molecules to get in that position. What I wanted to show you, before I guess I'll do another video, is I'll take another bottle of seltzer and I make sure this temperature isn't so cold so it doesn't freeze. There may have been some CO2 not in it as well. And by opening up the top and releasing the CO2 from it, taking out the colligative properties, the water would freeze by just shaking and opening the bottom. Okay? So that's that demonstration.